Hello students. In this video, we will learn about some very beautiful natural phenomena which are due to some special properties of light rays like reflection, refraction, dispersion and other also. We have done refraction and dispersion of light ray through a prism. Refraction, all of you know, just bending of light if it enters from one medium to other medium having different optical densities or different refractive indexes. Like if an light ray, it travels from air to glass, it will bend towards the normal, it will refract. And the other phenomena, dispersion, we have learned, and by the dispersion of white light a beautiful spectrum of 7 colors is made, and these colors are the colors of rainbow. And why this dispersion takes place? It is due to the fact that different colors of white light, there are 7 colors, 7 components of white light. These different colors of white light, they bend with different angles in glass, and their speed is also different. So all the 7 colors, they disperse into a beautiful spectrum of 7 colors. So this we have done in lab with a glass prism. But in nature, a beautiful rainbow can be seen in monsoons on a rainy day, and this rainbow has all the 7 colors which are the component of white light. So in this video we will see how this natural rainbow is formed in sky on a rainy day. So for a natural rainbow to be formed in the sky, 2 things are needed. One, the sunlight, and second, the water droplets in the atmosphere. These water droplets are there after a rain shower, and if sun shines, then the white light of sun or sun rays, they fall on water droplets, and there are millions and millions of water droplets, and an arc, a beautiful rainbow is formed in the sky for few minutes. So we will say what is the science behind this formation of rainbow. Where is prism in the atmosphere? We have seen that dispersion has taken place by the help of a prism. But where is prism in the atmosphere, in the earth atmosphere? So the tiny, this green colored round is a droplet, a water droplet. So tiny water droplets which are present in the atmosphere after a rain shower, they work as prism. What happened? Suppose here is sun. So sun ray, it falls on this water droplet. Inside water is there, outside air is there. So the 2 different mediums are there. This is rare medium and this is the denser medium, because optical density or the refractive index of water is more than the air. So when the light ray travel from a rare medium to a denser medium of this water drop, then what happened? Suppose here where this is the normal. So it bends towards normal. And first, when it enters water, it refract as well as disperse. So 2 phenomena takes place. One is refraction and second is dispersion. We have seen when we were doing prism. So refraction means bending of light. Why light bends? It bends towards normal because it is a denser medium, and it disperses also because different colors of white light, they bend with a different angle. This is the lower one is the violet and the upper is red. So it disperses into 7 colors and these 7 colors are in this order. So lowermost is violet and the uppermost is red. It disperses also at this interface as well as this ray refract also. Now what happened next? When these rays, all the 7 colors, these are all 7. All the 7 colors are in this beam. When this 7 colored beam, it falls on the internal wall of droplet, water drop. So this is the internal wall. What happens? It totally reflect and it is known as total internal reflection. Total internal reflection. It does not go out. It does not go out of the raindrop. It totally reflect. It is not refraction, it is reflection. It bounces back. It totally reflect from this surface. And after total reflection, it falls on this interface and from here it comes out in the form of a beautiful spectrum. All the 7 colors, they come out from this side. Again it refracted as well as dispersed. Why it is refracted? Because now it is coming from water to air. So it goes away from the normal. The angle here is more. It goes away from the normal. As this is dense medium, it is rare medium. So it refract also and it disperse also. Again dispersion takes place and all the 7 colors, they can be seen. This is violet, this is red. After the sun ray comes out of a water droplet. And there are millions of water droplets and the rainbow is a cumulative effect of refraction, dispersion, internal reflection, again refraction, again dispersion. All these phenomena takes place and we can see the rainbow in the sky. One condition is also important, that when suppose I am the observer, the sun should be behind my back. Then I can see the rainbow in front of me in the sky. So in this way, the beautiful natural phenomena of formation of rainbow takes place by these different phenomena of white light or a light ray. So this is about formation of rainbow. Now we will do the second important natural phenomena, and that is twinkling of stars. Here I have shown how the stars twinkle. At night, in the night sky, we see that stars, they twinkle. Twinkle means sometimes bright light comes into our ear and sometimes a faint light comes into into our eye. So sometimes brighter, sometimes fainter. The intensity of light, it changes every moment. So it appears as if the stars are twinkling, though they are very much stationary, but due to the different angles of light ray which comes to our eye, it seems as they are twinkling. We see the science behind this. These are, what is this? Twinkling of stars. Before twinkling of stars, one more phenomena is there, that is higher is the apparent position of a star. What is this? This is, see, this is our earth. The observer is standing here on the surface of the earth. These 3 lines, these 3 channels, they show the atmosphere around the earth. On the surface of the earth there is atmosphere, and this atmosphere is layered. Layered means different layers of air are there around the earth. What these layers are? This is earth. These layers are having different density. This is the most dense, this is in between, and this is the least dense. That their density is different. So this is the most light air and this is the most dense air. Due to this, different layers of different density are formed around the earth surface. Now what happened? Suppose this is a star. We know stars are very far away from us, from earth. Though they are bigger in size, sun is also a star, but this sun is the closest star to us. These stars, they are so far away from us that these looks like a point. So we call them a point size star because they are very much far away from us. So the light from the stars have their own light. So the light from the stars, it travels in vacuum up to the layers of the earth. So it travels into a straight line. When it enters the earth layer, the outermost layer, it bends towards normal. These red lines 1, 2, 3, they are showing the normal. Normal means a perpendicular line to this interface, the last one. So if this is the interface and this is the normal, this light ray, it bends towards normal because this is rare medium or in fact no medium, and this is the denser medium than this. Once it bends towards normal, it enters the second layer. This layer is denser than this, so it again bends towards normal. This is the densest, and so it bends again towards normal. Here is the observer. So the light, it comes into the eyes of the observer where it is a tilted line because refraction of light takes place. This bending is due to the refraction of light rays. Observer is here. We can see any image, any light in a straight line. We cannot see along this path. We see in a straight line. So this is the last ray which is entering the eye of the observer. So he sees this ray in a straight line like this. This is the line of vision of the observer. So this is not the actual star. This is the image of the star which we are seeing. This is actual star. This is image of star. Image. So this is image and this is actual star. So, and this image is slightly higher than the actual position of the star. Why? Why? Because we are seeing in a straight line. So the image, or this is the apparent position. The apparent star position is slightly higher than the actual position of star. This is one thing. Now coming to the twinkling of stars. Why stars? They twinkle. We have seen these rays. I have magnified these rays like this. This is the light coming from the star. This ray, when it enters this ray in this layer, if this is the normal, it bends towards normal. It bends as well as it has taken a zigzag path. Why this path is zigzag? This is the path of ray. This is again a normal. It is bending towards normal but taking a zigzag path. Why it is taking a zigzag path? Because these layers, they are made up of air, having dust particles, having nitrogen, gas molecules, and many other water vapor, many other things. So these are not stationary. They are always in motion. There is a slight turbulence in these layers. So the density is not fixed at a time. Sometimes it is denser, sometimes it is less dense. So due to the changing in the density, due to the motion in the atmosphere around the earth, these rays, they also have taken a zigzag path. When then zigzag path is there, so we will see sometimes here, and the next moment we will see here, according to the lines, we will see these stars at different positions in different time interval. Sometimes this star will be here, sometimes this star will be here. So the position is changing. When it is here, we are getting less light. We are standing at the same place. So when it is here, we are having a fainter light. When it is in the center, we are having a bright light. The next moment, we are again having a brighter or a fainter light. So the light coming to our eye changes at every moment. So it looks that the star is flickering. The light is flickering. So it looks as the star is twinkling. This is how the stars twinkle. Now one more thing. Planets are also there, but planets do not twinkle. They look like stars. In the evening we can see the Venus planet, which is very near to us, near the moon, very shining. It looks like a star, but it is twinkle. Why they do not twinkle? Why the stars? We see the Venus for 5 minutes, it will not twinkle. Why it is not twinkling? Because first, they are very close to us, very close to Earth. So they are not point objects. They are like disk. Second, they don't have their own light. They shine by the light of the other stars. And secondly, they are like disk. It means they have so many, suppose, point objects inside them, because they are bigger in size. And if the light is coming through a planet, what happens? Sometimes this falls a light on our eye, so it may be bright. The other moment, this is falling on our eye, it may be fainter. Next time bright, next time fainter. So the total effect, the average effect on our eye is the same light is coming through a planet. They don't twinkle, or they twinkle so little that the overall effect of the light rays coming from the planet looks like the same. So planets, they are disc-like, they are not point objects, so they do not twinkle. So this is about the twinkling of stars and twinkling of non-twinkling of planets. The third phenomena, the natural phenomena, which is also dependent upon the refraction of light ray. Now all of you very well know what is refraction of light. Refraction is bending in a different medium. If the medium is dense, it bends towards the normal. If the medium is rare, it bends away the normal. So this is refraction. The third phenomena is this. It is early sunrise and delayed sunset. Very beautiful, very important phenomena of nature. So what does it mean by early sunrise? The actual sunrise of sun. We will say what is how the sun rises. When sun comes above the horizon, then we say the sun has arisen. That is, the actual sunrise should be when the sun comes above the horizon. So in this is the diagram I have drawn. This is Earth, and this is the observer standing on the surface of the Earth. This line is horizon. Horizon, all of you know. In Hindi we call it Kshitij. So this is horizon. So what happens at the time of sunrise? The sun is still below the horizon. So it is not, sunrise is not there. We cannot say sun has arisen because it is still below the horizon. But what happens? The light ray from sun, it travels in the space, first in the space, and then it travels, it bends towards the atmosphere of Earth. If there would not be any atmosphere, it will go straight like this. But as it falls on the layers, atmosphere of Earth, due to its denser nature, it curves, it refracts. So this is, if this is the normal, it bends towards the normal. Suppose this is the second layer, here it is the normal, again it bends towards the normal, again it bends towards the normal. So this straight ray which is coming straight, when it enters the Earth atmosphere, it bends, and this curve is now falling, entering the eye of the observer. So still the sun is beneath the horizon, but the light from the sun is entering the observer. So, and when we can see the observer in a straight line, he can see the sun here. So this is not the actual sun. This is the image of the sun which is formed 2 minutes earlier of the sunrise. The sun actually will come above the horizon after 2 minutes. But before 2 minutes, its image, due to the refraction of the light, can be seen by this observer above the horizon. Likewise, the delayed sunset. Suppose the sun is set here, suppose at 7 p.m. or 6:30 p.m. the sun set and it comes below the horizon. But again the same explanation is there. At 10:30 the sun is below the horizon, but it is set, but the light ray coming from the sun going up and is still coming, it is still entering the eye of the observer. Again the observer can see the image of the sun 2 minutes after. So at 6:32 p.m. he can still see the sun. After 2 minutes, the sun has set, it has come below the horizon, but after 2 minutes also it can be seen by the observer above the horizon. This is not the actual sun, this is the image of the sun. So we can say early sunrise by 2 minutes and delayed sunset by 2 minutes has taken place due to the wonderful phenomena of refraction of light through the airs, through the layers of Earth. So these three phenomena we have taken: one, the formation of rainbow, then the twinkling of stars, and then this early sunrise and delayed sunset. In the next video, we will learn about some more natural phenomena due to light. Thank you.